What's up, calculus students? New 3-4 video because I changed a little bit of questioning from previous years to this year. So, great thing about 3-4 is that it's just lesson 2 and lesson 3 combined. So, we're going to look at the analysis of f prime and the analysis of f double prime on top of each other. Because if you know f prime and f double prime, you know the shape of your curve and you're a great human graphing calculator. So, first questions ask for sketching a portion of the function whose derivatives have the following characteristics. First of all, you got to be familiar with this notation, meaning your derivative is positive. So your first derivative is positive. That means your original function must be increasing. Your second derivative being positive means your first derivative is increasing. If derivatives and slopes are increasing, your original function is concave up. So f is increasing and concave up. It looks like this. All right, that's would be the shape of your curve with those characteristics. If your first derivative is negative, your original function is decreasing. If your second derivative is negative, your first derivative is decreasing. When your first derivative is decreasing, your function is concave down. It's all about the charts, baby. F is decreasing, concave down. To help you with this, like here is concave up, here's concave down. You could split it up and you could see like this is concave up decreasing, concave up increasing. This is concave down increasing, this is concave down decreasing. So I want to be going down and concave down. I look at concave down, I say going down, concave down. This is what my function would look like. Here my first derivative is positive, so my original function must be increasing. My second derivative is negative, which means my first derivative must be decreasing, which means my original function must be concave down. Look at concave down. Increasing concave down would be this portion. First derivative negative, function is going down. Second derivative is positive. First derivative is increasing. My function must be concave up. Going down, concave up. I look at concave up. Going down, concave up. Looks like that. Now we get to these words that sometimes confuse students. And if you try to just look at the words and sketch, a lot of you are going to be wrong. If you say f is decreasing at an increasing rate and you're thinking, okay, it's got to be going down and going faster down, you're wrong. This is wrong. That's wrong. Sometimes like our mental thought about increasing is actually the wrong way to think about increasing. It's not increasing means numbers are getting bigger. It means increasing, our numbers are going up. Here's how we can handle this. F is decreasing. Okay, F is decreasing. You could just leave it like that. You don't need, if you wanted to, you could say F prime is negative. Your rates, which are your slopes, are increasing. Rates of change are slopes. If you say slopes, if you say increasing rate, you're saying your slopes are increasing. You're saying your derivatives are increasing. Now we know from our second derivative sign analysis that if our derivative is increasing, our original function is concave up. So it's not going down concave down. It's going down concave up. Now, why is this an increasing rate? Well, our slopes are -4, -3, -2, -1, 0. -4 to -3, -2 to -1. Everybody thinks, oh, those numbers are getting closer to 0. They're decreasing. Wrong. -4 to -3 plus 1. We increase 1 to get from -4 to -3. -3 to -2. -2 to -1. -1 to 0. Those are increasing numbers. So it's not about faster down. It's about your slopes are increasing. So just be careful out there. Decreasing at a decreasing rate, again, if you're just sketching it down, you're probably doing it wrong. You're probably thinking it's that. You're decreasing, but you're going slower. No. Decreasing rates means your slopes values are decreasing. If your slopes values are decreasing, your function is concave down. Okay, so we kind of translate rate into slopes, decreasing slopes. Boom, we have our second derivative chart, just a little bit of it. F is going down, concave down. This is correct. Okay. More words. F's rates are positive and decreasing. F's rates, slopes. The rates of F are positive. The rates of F are decreasing. If F's rates are positive, F is going up. If F's rates are decreasing, F is concave down. You can add, that's a down arrow. You can add the whole F double prime must be negative. You don't need it though. F rates are positive and decreasing, function must be going up and concave down. F rates are positive and increasing. F's rates, its slopes, are positive. The slopes are increasing. My function must be going up and concave up. Cool? Now, I could give you a table of values and ask you what are the signs? Like, what's going on here? Are you increasing, decreasing? Are your slopes positive or negative? Are your slopes increasing or decreasing? Now, there's two ways to do this, and having two ways to do things sometimes freaks students out. But one way, which I don't think is the good way to do it, is to kind of sketch. And you're like, okay, I got 1, 1, I got 2, 3, and I got 3, 7. I can see I'm probably increasing concave up. Now, a lot of you won't sketch this correctly, or your sketch will be a little bit deceiving to you. So instead, you could look at the slopes. Like from 3 to 1, I increase 2 y's per 1x. 7 to 3, I increase 4 y's. Think of these as your rates of change, your slopes. Well, your slopes are positive, and these slopes, 2 to 4, are increasing. F prime is positive, F prime is increasing, F is going up, F is concave up. So yes, it is what we kind of see, but again, the graph might be deceiving. Now here, we're asked for the signs of F and F prime and F double prime. You need to go that extra step of if your slopes are increasing, your second derivative is positive. Okay, same thing, 7 to 3 to 1. If you want to sketch 7 to 3 to 1, you might be able to see that this is decreasing concave up. Or you can look at your rates of change. I go down 4, I go down 2. Now this is confusing to students, but to get from -4 to -2, we increase. We like add 2 to get from -4 to -2. So, honestly, this might be confusing to some of you, and this might be like easier for this one. My slopes are negative. My function is going down. My slopes are going up from -4 to -2. That means my second derivative must be positive, or the rate of change of the rate of change is positive. There you go. There's that positive. F is concave up. So answer is F prime is negative, F double prime is positive. Don't love this example because I'm increasing 3, then decreasing 1. So I'm going to have a max somewhere. I don't know exactly where my max is going to be, but like F prime is changing signs. My slopes are decreasing. The minimum thing I could say is most likely, honestly, I want to just skip this. Let's change this to 9 or 8. All right, cool. What's going on? Changing that to 8, change the question. My slopes are positive. The rates of change of my slopes are 0. Why? From +3 to +3, 0. My rates are neither increasing nor decreasing. My slopes are positive, but their slopes are 0. I would say this is like a linear function where we have no concavity. F prime is like constant. F has no concavity. So F prime positive, F double prime is probably 0. And that's actually what this guy is. up to. My rates of change are positive. Their rates of change are 0. Same deal here. Let's do this. I subtract 2, I subtract 3. Again, if you sketched it, maybe you were able to see 1, 1. Oh, this is probably bad. 1, 1, 2, negative 1, 3, negative 4. We're decreasing concave down, or my slopes are negative. From negative 2 to negative 3, I subtract 1. The slopes of my slopes are negative. Or my slopes from negative 2 to negative 3 are decreasing in their values. So F is going down, F is concave down. You could work from the graph to start here and then fill out the rest of your charts, or you could start with the slopes. It's up to you. F prime is negative, F double prime is negative. Here, plus 0, plus 0, plus 0. My slopes are 0. Their slopes are 0. Constant. All right. Given a function where we're not asking you to sketch the entire thing. It used to be in AP Calculus classes and in a lot of Calc 1 classes in college. Curve sketching, human graphing calculator, big deal. You spend a lot of time just like doing a full-on curve sketch. In AP Calculus, they kind of ask you to understand the concepts behind curve sketching, but then find specific parts of our function that have specific characteristics, okay? So to answer these questions, what we're going to do is like our full-on sign analysis of both our first and our second derivative. We're going to do step 2 and step 3 of human graphing calculating. So we're going to take our first derivative. We're going to set that equal to 0. We will throw down our first derivative sign analysis. Make sure you have it labeled. I tell you kids to label it, and you don't. But it's important because the signs of f prime tell us if f is increasing or decreasing. Use multiplicities, do test points, whatever you want to do to get that. Now, to find our second derivative, I'm not going to go off the factored first derivative. I'll go off the unfactored because it's easier to do. I get 6x minus 12, and I get x equals 2. So on top of this first derivative sign analysis, I will have a second derivative sign analysis. Our second derivative sign analysis, which is positive and then negative, tells us about our first derivative increasing and decreasing, which tells us about the concavity of our original function. Okay, so sign of a derivative tells us about if the original thing is increasing and decreasing. That means the second derivative tells us about the first derivative increasing, decreasing. First derivative increasing, decreasing, functions concavity. So let's start with increasing, concave down. Okay, increasing is here and here. Concave down is here. So we're looking at just when they do both at the same time, the answer to number 1 would be negative infinity to 0. That's when we're doing both. Okay, now watch this. Decreasing at a decreasing rate. Okay, maybe we can translate this. F is decreasing, that's right there. F's rates are decreasing. F's rates are decreasing right there. Okay, so this is decreasing, rates decreasing, 0 to 2. If you want to translate decreasing rate means concave down, that's fine. Or if you're using the charts, it's all there in the chart. You can answer every question as long as you have all layers of every chart. All right, next one. Okay. First derivative sign analysis, 0 and 2. The signs are going to flip. If I plugged in 3, positive, negative, I will change signs because of the multiplicities. Have stuff labeled, that's telling you F is decreasing, increasing, decreasing. Too many of you are not going to label things. You're going to think, oh, this is easier, Mr. Mester. Why do I have to show all this work? This is stupid. I know what I'm doing. And then you're going to make mistakes because you honestly don't know what you're doing. Take the derivative. I get 18x minus 18. Sorry, 18 minus 18x. And I get x equals 1 there. If you want to factor out an 18 and do that, that's fine. On top of things, I like to have them stacked on top of each other with our numbers lined up. I think it helps. Sign analysis, if I plugged in 2, it'd be 18 minus a bigger number, so that's a negative. If I plugged in 0, it'd be a positive, or we can know that changes signs. That means f prime's increasing then decreasing. That means f is concave up, concave down. We have everything we need now to answer the questions. Let's start with this one. F is decreasing, F is concave up. F is decreasing, F is concave up. So where do these overlap? Again, it's going to be from negative infinity to 0. Cool. Now for the next question, F is increasing. Okay, F is increasing. F's rates are increasing. So the F primes, the rates of change of F are going up. The rates of change of F are going up. Boom. Where are we doing both? From 0 to 1. All right. (20x cubed minus 5x to the 4th). 5x cubed factored out. X minus, 5 minus x. (4 minus x). I'm a little bit brain foggy from ACL still. Not because of reasons anything different than I got sick. And I'm going back to ACL tonight. Weekend 2 with just mom and dad, no kids. So hopefully I make it. We'll see what happens on Monday. Might be out. Who knows? I'm not going to be out. Got to push through. All right, if I plug in 5, positive, negative. This is a cubic. That means we will change signs to the left and right of 0. This is a first power, so yeah, signs are going to change. F decreases, increases, decreases. I look at the second derivative off of my unfactored first derivative. I get 60x squared minus 20x cubed. I factor out a 20x squared. I get 3 minus x. I could spend some time like graphing these in Desmos and seeing like our beautiful work. But, we're not asked to sketch everything, but we have all of our capabilities to sketch everything. All right, our second derivative has a 0 at 0 and at 3. Okay, so see that is in common, so line them up. I have negatives to the right of 3. I won't change signs at 0. We can use test points to check, but like that square means the factor x squared to the left and right of the 0 will stay positive. So I will change signs at 3, but I won't change signs at 0. That's telling me f prime increases, decreases. When your slopes increase, your function is concave up. We have this situation where we have a point of no concavity, where we're going to be decreasing concave up, increasing concave up, but we will be flattening out so much that there's like a point where we're linear. All right. Who cares? Let's just answer the question, right? F is increasing and concave up. Okay, F is increasing, F is concave up. Okay, so from 0 to 3, we're doing both. F's rates are negative and decreasing. F's rates are F prime. F prime is negative. Okay, we can just look right here. F prime is negative. F prime is decreasing. F prime is decreasing. That's how we could do this. Like, you have everything you need. So no matter how they ask the question, you have the level to look at, whether it's the sign of a derivative, F going up or going down, et cetera, et cetera. So this would be from 4 to infinity. Great. All right, cool. I could factor this some more if I wanted to, but I don't have to. As long as you know that positive and negative 1 and 0 are all of our critical points. Negative 1, 0, positive 1. Label. Our root of 0 won't change signs to the left and right of 0. You can use test points to check it. If you plug in 2, positive, 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 I will change signs. I won't change signs. I will change sign. F, therefore, has to go up, go down, flatten out, but then continue to go down, then go up. Okay, so we have a max at negative 1, a min at 1. If I look at my second derivative, I get 4x cubed minus 2x. I factor out a 2x. I get x squared, 2x squared minus 1. All right, it's a little annoying, but we can handle it. If I wanted to solve this, it's probably easier than to factor it. You have 2x squared minus 1 equals 0. You get x squared equals 1/2. You get x equals plus or minus root 1/2. That's a value, okay? Those are possible points of inflection. We also have x equals 0 from this one. So what we need to do is, yes, focus on 0. It will change signs at 0. This kind of makes sense with what we think the graph looks like, which is going up, going down, flattening out, going down. We'll like have a point of inflection, but not a minimum. You'll see. And in between the ones, we have this negative root 1/2 and this positive root 1/2. If you wanted to, you could understand that this would factor like as a difference of squares. It's like root 2x plus 1, root 2x minus 1. But like you could also use test points. Let me show you how to use test points on this one. Plug in something like 5, positive, positive. Okay, that's positive. I can plug in something like 0.000001. This factor is positive. 0.000001 squared times 2 is going to be a very small number if you think about plugging in a very small number. That very small number minus 1 is going to be a negative, which is why, like, yes, I'm going to change signs. I definitely know for a fact that x equals 0, that's multiplicity is 1, means we will change signs. So that's kind of taking care of the rest. And if you wanted to plug in like negative 50, negative, this will be a positive because negative 50 squared will be bigger than 1. So negative times positive is a negative. It's telling me about f prime decreasing, increasing, decreasing, increasing. F is going to be concave down, concave up, concave down, concave up. Great. So this kind of makes sense. Like I'm going up. How do I do this? This way. I'm going up, concave down. I hit a max. I start going down, concave down, but then I have a point of inflection. The point of inflection is at negative root 1/2, where I start to go down, concave up, where I flatten out. One of those critical points that's neither a max or a min. Then at that critical point, neither a max or min, I change concavity again. So I start going down, concave down, and then I go up, concave up from there. So like if you wanted to sketch it, you could. We're just going to answer the question. F's rates are positive and decreasing. Okay, I look at F prime. Let me stay in black here. F prime, positive, F prime, decreasing. All right. F prime, positive. f prime decreasing. So this would just be from negative infinity to negative 1. F is decreasing. All right. F is decreasing. At a decreasing rate, F's rates are decreasing. F's rates are decreasing. So decreasing rate will be from 0 to root 1/2. All right. Oh. I'm immediately regretting asking this question. We're set up to find f prime sign analysis. Great. I need some space here. Negative 1 and 3/2. Give me a second. Hey. Yes, for you. Yeah. Yeah. I believe I have 40 for you for the second quiz, and then I have. Okay. I will. Yeah, I'm making a video right now, but I can read now after. 20 minutes. Okay. Sorry for the delay. Didn't want to pause it. I plug in something like 50, positive, positive, cool. Multiplicity of this 2x minus 3 root of 3/2 is 3, which means we will change signs to the right and left of 3/2. But the multiplicity of negative 1 is 2, which means this factor will remain positive, which means we will not change signs. It's not that it will remain positive, it's that this won't change signs, so this will stay negative. All right, so f is decreasing, decreasing, increasing. Cool. Now, how do I figure out when this is concave down? I need to find the derivative. This is a product, and inside the product, you'll have to do a chain. You haven't done a chain in a while. Don't worry, it's coming back next unit in a big way, so don't forget about it. The derivative of the second piece is 6. What starts in the parentheses stays in the parentheses. I don't want to do this question. This is going to take me a while, but here we go. The derivative of the first also kind of requires the chain rule, but not really, because the derivative of the inside is 1. The derivative of the outside is 2 stuff. So the derivative of the first times the second plus the derivative of the second times the first. What the heck do we do now to find when this is equal to 0? Well, we have to factor. Think of this as 2yz cubed plus 6z squared y squared. I can factor out a 2, a y, and a z squared, leaving me with just z and leaving me with 3y. Oh, that's fun. Yeah, if you are like, Mr. Muster, this is ridiculous. I kind of agree with you. Z, 3y's, 5x. The 3's go away. Well, that's nice. All right. What's that mean? This is my second derivative. This is my second derivative factored. We will still have negative 1. We will still have 3/2. Negative 1 from this, 3/2 from this. But from this guy, we get 0. All right. We won't change signs at 3/2. We'll change signs everywhere else. If I plug in something big, that'll be positive. This will stay positive. This will switch to negative. This will switch to a positive. F prime is increasing, decreasing, increasing, increasing. F is concave up, concave down, concave up, concave up. F is increasing and concave down. F is increasing. F is concave down. Never? Great. F is concave down just here. F is decreasing at a decreasing rate. So that's the rates decreasing. F is decreasing. F's rates are decreasing right there, -1 to 0. All right. Cool. Let's get through these and then we will start moving on to graph problems, which are my favorites and your least favorites, and you have to pay more attention on. Let's do these actually first. I'm giving you the rates of F, but in this type of table. So rate of change of F, making sure you understand that this is F prime. This is F prime positive. This is F in prime increasing. F prime negative. F prime increasing. F prime positive. F prime decreasing. F prime negative. Negative. F prime decreasing. Where does F have a relative extrema? All right, well, if you want to convert this, it looks like we got this, 1 is our start to 2, 2 to 3, 3 to 4, 4 to 5 is where we kind of end. F prime is positive, negative, positive, negative. That means F's got to increase, decrease, increase, decrease. X equals 2 is a max. X equals 3 is a min. X equals 4 is a max. Where does F have points of inflection? Well, we could throw down our second sign analysis where we know F prime increases, increases, decreases, decreases. And again, it's 1 to 2, 2 to 3, 3 to 4, 4 to 5. So that means F double prime is positive, positive, negative, negative. That means F concave up, concave up, concave down, concave down. Okay, it's a kind of like taking that, put it into a sign charts, filling it out. Points of inflection is just at X equals 3, where our concavity changes. When is F increasing, concave down? When is F increasing? F concave down? Oh, never. You don't have positive and, right here, 3 to 4. Oh, I just missed it. F increasing, F concave down, 3 to 4. When is F decreasing? Switch colors. F is decreasing, F is decreasing. The rates are decreasing. The rates are decreasing, 4 to 5. Cool. So that covers this. Now, these questions are actually questions I could kind of put with the mean value theorem if I taught the mean value theorem at the end, because they are questions that a lot of students really don't understand because they think they know what's going on when they give a table. But in reality, when you're given a table, you only have limited information. You have answers to could, but you don't have answers to must. What do I mean by this? Like, you look at this table and I say, like, what must be true? And you look at this table from 1 to 3 and you see 10 to 15 to 17 and you're like, oh, my rates of change are positive. We go +5, +2 for our rates of change. So you're like, oh, F prime is positive. Well, the problem with this is that could be true. It's most likely true. But heads up, we're going to practice this too next class. There's a difference between could and must. Most likely and always. In mathematics, it's very important, that difference, could and must. Why do I say could be true and not must be true? Why do I say this is most likely true? Well, because there's a possibility that between 110, 215, and 317, that we don't just connect like that. That's a could. That's a most likely. But you don't know for a fact that your function goes like that. Maybe your function decreases and increases between 1 and 3. All you know is that you have a select set of points. So it could be true. It's most likely true, but not always. And that's the answer. Like, this is not must be true. This is a could be true. This is a most likely true. You look for 1 to 3 and you're like, oh, if my rates are increasing, but the rate of change is negative, or my graph is probably concave down. Yeah, most likely. Sure, could be. But does it have to be? The answer is no. Like, yes, on our previous questions here with these tables, we are saying what would be an educated guess. It is not saying what must be true. These answers are all could be's. Oh, I should have put a positive here. Yeah, it's like most likely my slopes are this and this. Well, I don't know what my cursor's doing right now. Most likely my slopes are this and this. Do my slopes have to be this and this? Actually, no, because we don't know. So again, make sure we pay attention to the question. And on your test, there's going to be like coulds, most likelies, or musts. And yes, you can see right here, I can connect the graph like this. And here we have some portion of the graph where we're concave up. So this one is a not always. We might think that at 3, we hit a max. We might think that we go from 110, 215, 317, 412, 510. You must think, oh, that's got to be a max where the derivative is 0. Yeah, could be true. Most likely it's true. But couldn't it be the situation where maybe it's on the way down when it goes through that? Maybe the max is before that. Maybe the max is after that. All I know is that between 2 and 4, we do have to go up and go down. We will have a max somewhere, but we don't know for a fact that it has to be at 3. So really all of these questions, except for one question, is could be. Same here. Not always. Could be. Most likely it's true. -5, -2. Looks like my slopes are negative and my slopes are increasing. My second derivative is positive from -3 to -2. The only thing we do know is that there has to be a 0 derivative somewhere between 1 and 5. Why? 2 reasons why. One reason, you know your function goes from increasing to decreasing. You know your derivative is positive because we have to be going up, from 10 to 15 to 15 to 17 somewhere. And you know your derivative has to change signs to negative. That's one way. The other way is the mean value theorem. Mean value theorem says your function is differentiable. Now it says twice differentiable. That just means you can take the derivative twice. Doesn't mean this is the second derivative. This is just our f. That's probably a good thing to say. Like whenever you read twice differentiable, don't assume you're given the second derivative. It's just like that's f, and you can take the derivative twice. The mean value theorem says there has to be a derivative equal to your secant slope. Well, my secant slope between 1 and 5 is 0. So that means I have to have a tangent slope. So no matter how you connect all your points, yes, this always has to be true no matter how you connect the points. This is a good little review for a couple test questions you're going to see, and we're going to practice them more. All right, to my favorite questions, the graph questions. Ready? Didn't really focus on it last class as much, last homework video. I kind of did everything. But here for these questions, focus on the charts. Don't look at the graph yet. Look at the question first. Create this chart first. F is increasing, F is concave down. I'm going to start with this. F is increasing. Okay, its derivative's got to be positive. Filled out the chart for F increasing. F is concave down. Okay, that means its derivative's got to be decreasing. That means its second derivative's got to be negative. I just filled out the charts. Okay, now I look at what I have. I have the graph of F prime. So I will focus my attention on the F prime parts of my charts. I want to know when is F prime positive and going down. That's when F will be increasing concave down. F prime will be positive and F prime going down. Remember, F prime is 0, is negative, is positive by looking at the values of F prime. Then F prime is going up, going down. Or you can look at the slopes of F prime being negative. When is F prime positive and going down? Here's when F prime is positive and going down. The answer is from 0 to 2. You could also say F prime is positive but having negative slopes. These are F double prime values. The slopes are negative. F is decreasing at a decreasing rate. Okay. Start with the chart. F decreasing means F prime has to be negative. F's rates are decreasing. The rates are decreasing. Okay, F double prime has to be negative or F has to be concave down, but really, decreasing rate is perfect because I have the graph of F prime. Let's change colors here. F prime is going down. F prime is negative. Where are we? Negative and going down. Well, negative going up, positive going up. Positive going down, negative going down. So x is bigger than 2 or 2 to infinity. Cool. Start the charts. All right, the question. F is decreasing, concave up. Okay, F is decreasing. F prime has to be negative. F is concave up. Okay, F is concave up. That means F prime must be going up. That means the second derivative must be positive. What do I have? The graph of F prime. Okay. I will look at when F prime is negative and when F prime is going up. That's what I have, the graph of F prime. When is F prime negative and going up? Okay, positive going down, positive going up, positive going down. Negative going down, negative going up, right there between 2 and 3. It's a lot easier to do it this way than to go ahead and do all of your signs of your first and second derivative. It'll just take a while to do that, though you could. F's rates are positive. Okay, ready? F's rates, F prime, are positive. F prime is positive. That means F is going up. F's rates are decreasing. Okay, F prime is decreasing. You have everything you need. You don't even have to fill out the chart here because they're telling you about F's rates. Like F's rates, change colors, are positive. I'm looking at F's rates. F's rates are decreasing. When are we positive and decreasing? Positive and decreasing. Positive and increasing, positive and decreasing. So from negative infinity to negative 2 and from 0 to 1. All right, now it's asking you about everything. How many critical points do we have? Critical points you have are when F prime equals 0. Okay, when does F prime equal 0? At negative 2, 1, and 3. So we have 3 critical points. What are the relative extrema? Where does F prime change signs? Here and here, we change signs from a positive to a negative. I'm not going to do the whole sign chart because it's going to take a long time, but if you want to, you can. X equals 1, F prime changes signs from positives to negatives. If F prime goes from positive to negative, F has to go up then down. X equals 1 is a max. X equals 3. F prime just changes signs from negatives to positives. F prime changes signs from negatives to positives. So that means that's got to be a min. X equals 1 is a neither. X equals negative 2 is a neither. So it's a critical point that's not a max or a min. So I'm not going to list it. Points of inflection. So you can kind of tell when we've done this, when F prime changes direction, F has to change concavity. When F double prime changes signs, F has to change concavity. You can look at the graph of F prime and see where does it change direction or where does it have a max or min. Those are going to be the locations of your points of inflection. So x equals -2, 0, and 2 will be the points of inflection because that's where F prime changes direction. That's where F double prime will change signs. That's where F's going to change concavity. All right. Let's start with this one. F increasing concave down. Oh man, I gotta go. I'm gonna have to pause. F is going up. F prime's got to be positive. F is concave down. F prime's got to be going down. F double prime's got to be negative. Look at the chart. This is F prime. F prime is positive. F prime is going down. Where are F prime positive and going down? So from -infinity to -3, and from 0 to 1. Critical points 1, 2, 3. Relative extrema, x equals -3 is a max. X equals -1 is a min. Points of inflection are going to be at -2, 0, and 1. All right, I'll pause and finish this video during lunch. See ya later. All right, I did the classic error again of closing out all of my Chrome tabs. So I'm going to have to combine two videos. Hopefully I can do this. Excuse me. Eating lunch. Here we go. One is F increasing in concave up. Did I answer the question? Great. Start with the chart. F going up, F concave up. That means F prime is positive. That means F prime is increasing. F double prime is positive. Great. I have the graph of F prime. One is F prime positive and one is F prime going up. Positive and going up, positive and going up. -3 to -2, 1 to 2. F decreasing, concave up. F decreasing, F prime is negative. F concave up, F prime increasing, F double prime positive. Okay. I have F prime negative and increasing. F prime negative and going up. F prime negative and going up. So that's -infinity to -3 and from 0 to 1. If you haven't done any of these problems yet and you're just watching this video and copying down, it's like you're not helping yourself out. F is decreasing. That means F prime is negative. F's rates are decreasing. All right, well, that's like covers that. You don't really need anything else. F prime is negative. F prime is decreasing. There. -1 to 0 and 3 to infinity. Okay. Now, start the chart. Don't look at the graph yet. F prime positive. Okay, F increases. F double prime positive. F prime increases. F concave up. Okay, what do I have? The graph of F. Let's look at the graph of F. When is F going up and concave up? Okay, so I actually have to look at the curvature of this graph. How it's curving, how it's going up and down, how it's curving as it's going up. Now they give you a very huge hint here to help you. F is concave up until 1. F is concave down after 1 because we have a point of inflection at 1. So here's where we're concave up. Here's where we're concave down. Here's where we're going up and concave up. The answer is from 0 to 1. When is F decreasing, but F's rates increasing? Again, this is the one that people get screwed up on because they think decreasing at an increasing rate means that. It's actually not true. Thanks, man.
Yes, sir.
I'm looking at F, so I'm going to this layer of the chart. When are we decreasing concave up? Decreasing concave up. That's when I'm going down but curving upward. So that's negative infinity to 0. This next question is a fun one. Order from least to greatest. F of 2, F prime of 2, F double prime of 2. Well, let's look at 2. Okay, here's 2. What we have there is a y-coordinate, a slope, and a curvature. All three things you can see. You can see the y-coordinate, you can see the slope, and you can see the curvature. Could you answer this question after knowing that? This y-coordinate is a positive value. I don't know, 1, 2, something like that. Like f of 2 is positive. What is the slope there? Well, it looks like the slope is 0. Slope is 0. The y-coordinate's positive, so f prime of 2 is 0. What's the curvature there? We are concave down. If you are concave down, then your derivatives are decreasing, your second derivatives are negative. The second derivative is negative. So if you want to order it from least to greatest, well, the negative thing is less than the 0, which is less than function value. Okay. Points of inflection at -2 and at 0. Start the chart. F prime negative, F is decreasing. F double prime negative, F prime is decreasing. F is concave down. This is F. When is F going down? Concave down. So this is concave up, concave down, concave up. This is going down, concave down from -1 to 0. F is decreasing. Okay, F prime is negative. F's rates are decreasing. That means F double prime is negative. That means F is concave down. Okay, decreasing rate, concave down. You could look at when F, since this is the graph of F, when is F going down and when is F concave down? So important to label things correctly. It's the same question. Going down and concave down. Should have picked that up. -4. -1, 2, 3, 4. Right there. I got a y value, a slope, and a curvature. The y value equals 0. The slope I know is negative. Tangent slope. The curvature, it's got to be, we're concave up, so that means the second derivative's got to be positive. So here, my first derivative is less than my function value, which is less than my second derivative. All right, we made it. Hopefully everything saves. Or moves. F prime less than 0 means F prime is negative. When F prime is negative, F is decreasing. F double prime is positive, means F prime is increasing, means F is concave up. I have the graph of F. When is F going down but is concave up? Points of inflection are at -1 and 1. When am I going down but concave up? Here's where I'm concave up. Here to here, this is going down concave up. -1 to 0. Rates of F are positive. F is going up. Rates of F are decreasing. F is concave down. do this. Yes. F is going up and concave down. There's going up, concave down. There is going up and concave down. So we got negative infinity to -2, and we got 1 to 2. Y value, slope, and curvature. The y value is 0. Sorry, the y value is negative. The slope is 0. The curvature is positive. So y value is less than the slope, which is less than the curvature. Cool. Let's hope this works.